Okay, guys, so this is the first problem of the free response practice that we did. I hope that you find this understandable and useful. So let's start by reading out the problem. Two small blocks, each of mass m, are connected by a string of constant length 4h and negligible mass. Block A is placed on a smooth tabletop, smooth, of course, meaning no friction, as shown above, and block B hangs over the edge of the table. The tabletop is a distance 2h above the floor. Block B is then released from rest at a distance h above the floor at time t equals 0. Express all algebraic answers in terms of h, m, and g. Determine the acceleration of block B as it descends. Now, in order to do that, of course, we need to first analyze what the forces are. So let's look at block A, and we can see that you have a gravitational force mg, a normal force that opposes the gravitational force Fn, and the tension in the string T. It is natural to think that block A is going to accelerate to the right. In the case of block B, we have a gravitational force mg pulling it down and the tension T pulling it upwards, and the acceleration is, of course, downward. You can notice that the acceleration is the same for both of them. We do this because the only way to determine this acceleration is by making a system of two equations. So let's start by working with block A, in which case we have that the only force in the direction of acceleration is the tension. So your tension is equal to mass times acceleration. And in the case of block B, if we make positive the direction of acceleration, we have mg minus the tension is equal to ma. Therefore, when you combine these two equations, what you have is that mg is equal to twice ma because the tensions cancel out. Therefore, the masses also cancel out, and the acceleration is g divided by 2, or 4.9 meters per second squared. So that will be your answer for part A. Block B strikes the floor and does not bounce. Determine the time t1 at which block B strikes the floor. Now this is a classic kinematics problem. The two blocks started from rest, so the initial velocity is 0. The displacement, which happens to be in the y direction, is h if we take positive to be the downward direction, and the acceleration is g over 2. They want you to get the time, which they call t1. The one equation that includes these four variables is number 3. Displacement is equal to initial velocity time plus 1/2 acceleration time squared. Displacement is h, initial velocity 0, acceleration g over 2, and the time is called t1. 0 times anything is 0, so what you have is 4h divided by g is equal to t1 squared. Therefore, t1 is equal to 2 times the square root of h over g. And that is your answer for part B. Part C. Describe the motion of block A from the time t equals 0 to the time when block B strikes the floor. You can notice from the free body diagram that block A is accelerating due to the fact that there is a tension going on on the string. Therefore, all you have to say here is that the block A starts from rest and accelerates constantly, and that will be enough. A description of motion has to say that it moves, that is implied in the word accelerates, and of course, in this case, it is necessary to say that the velocity is changing due to the fact that the block is not in equilibrium. D. Describe the motion of block A from the time block B strikes the floor to the time block A leaves the table. Now, in that case, they're talking about the interval from the moment that block B hits the floor over here. Block A is a distance h from where it started, but now the string becomes slack. There is no tension anymore. If there is no tension, then there is no reason for block A to accelerate. So you can assume that the velocity will be constant. And so your description will be block A moves this distance at constant velocity. Finally, they ask you to determine the distance between the landing points of the two blocks. Now, consider the fact that block B is falling directly downward. So when it hits the floor exactly at the same x position that it had at the beginning, which you can call 0. On the other hand, block A is moving with a constant velocity, and it will move in a parabolic path. You want to find this distance, delta x. Now, this has become a projectile problem, and in that projectile problem, you can have several pieces of data. For example, block A started out with an initial velocity of 0 over a time interval, which we just found out was 2 times the square root of h over g, and with an acceleration of g over 2. This can help us to get the final velocity, which is going to be the x velocity a times t. So this is 0 plus g over 2 times 2 times square root of h over g. And this simplifies, if you look at it closely, 2 cancels out, g can go into the square root as g squared, and so this has become g times h. Look at it slowly and you'll see that it's right. Therefore, if your x velocity is the square root of g over h, all you need now is to find out how much time the block took to fall down. Let's call that t2. Once we get that, then the displacement is going to be the x velocity times t2. Now t2, the time that or the y motion, the initial velocity is 0. We do not know the final velocity. The acceleration is g because it is now in free fall. Acceleration is g, and we have that the displacement is the whole height of the table, which is 2h. So delta y is equal to 2h, and we want to find the time. The one formula that includes these four variables is number 3. So displacement is equal to initial velocity time plus 1/2 acceleration time squared. 2h is equal to 0 times t plus 1/2 g t squared, t2 squared. And so 4h over g is equal to t2 squared. Therefore, t2 is equal to 2 square root of h over g. Now, once we have this time, your displacement is going to be the x velocity, square root of gh, times the time, which is 2 square root of h over g. And so you have a 2 in front, square root of g h squared over g, which means 2 times h. Therefore, the distance that the block A falls is equal to 2h. And that is the final answer. I advise you please to check with the scoring guideline to see how much points each of the items is worth. Thank you for your attention.